Hello friends, in today's question, a wave represented by equation y is equal to a cos of kx minus omega t is superimposed with another wave to form a stationary wave such that the point x is equal to 0 is a node. The equation of the other wave is, so we have to find out the equation of superimposed wave with respect to this particular equation such that we form a stationary wave and the point at x equal to 0 is a node. So first of all, let us try to understand what is the meaning of a node and what is the meaning of a stationary wave, what is also called as a standing wave. So let us try to understand what is our nodes. So there are, you can say, three distinct properties that are, or properties, or rather we can say characteristics that are associated with a node. Okay. So first is, it is a point along a standing wave where displacement is 0. We can say it is a point on the standing wave where displacement is 0. Where displacement is 0. Second property, it states that at a node the destructive interference is going to take place and that results between two overlapping waves that form a standing wave. Okay, and the standing wave basically means that the particle of the medium is remain stationary. We will discuss that on later on also. So you can say at a node destructive interference occurs between two overlapping waves that results in a standing wave causing the particle of the medium to remain stationary. Now the third property, which states that node occurs at the interval of the half wavelength in a standing wave. So if the wavelength is lambda, then the node will be at the interval of lambda by 2. You can say that node occurs at interval of half wavelength so which basically means lambda by 2 in standing wave. So these are the three characteristics. There are many characteristics, but these three are important ones, especially directly related with this question. Okay, and let us try to understand what is the meaning of standing or a stationary wave. Standing, or we have stationary wave. So stationary wave, you have to remember rather that it is a result of superimposition of two waves, and these two waves should be having same frequency, same wavelength and same amplitude. This is very important in order to, you can say, in the formation of stationary wave or standing wave. Okay. So we can say from here that it results due to superposition of two waves having same frequency, wavelength and we have amplitude. And another thing is that for the formation of stationary wave, these two superposition waves should be traveling in opposite direction. Okay. So they should be traveling in opposite direction. Okay, so we can say same but in opposite direction. Now if they do not have, you can say, similar frequency, wavelength or amplitude, then it results in another form, you can say another formation, and that formation is also called as a beats. Okay, when there is a minor difference between the frequency or wavelength or amplitude, I rather say frequency and wavelength, then it results in another phenomena. That phenomena is called as a beats. Okay, so for standing waves or stationary wave, the frequency, wavelength, amplitude should be same, but these waves should be traveling in opposite direction. Now we come to the name, why it is called as a standing wave. It appears that the wave is standing still, but actually what happens, it oscillates at its, you can say, particular place without propagation. Okay. So we can say that standing waves appear to be standstill, that is, it oscillates in a place without propagation. So we can say the points which are stationary are called as a nodes, and which are oscillating are called as a antinodes. So therefore we can say stationary called as a nodes and oscillating, these are called as antinodes. So this is the basic understanding of the, you can say, standing wave as well as nodes, because this question is mainly related with two parts. So let's start with the question. So we are given that we have a wave which is represented by the equation y is equal to a. So we can say given equation of the wave y is equal to a cos of kx minus omega t, and here A is our amplitude, k is the wave number, and that k is equal to 2 pi by lambda, and omega is the angular frequency, and x is the position along the we can say wave propagation direction. So you can say here A is our amplitude, x is the position along the wave's propagation, position along the wave propagation. K is our wave number, which is sometimes also called as a spatial in the space as a term. K is the wave number, or it is also called a spatial frequency, which is equal to 2 pi by lambda, and omega is the angular frequency. Which is obviously equal to 2 pi f. So it means for the given wave to produce a standing wave, this wave should be superimposed by another wave, should be having the same amplitude, it should be having the same frequency, and it should be having the same wavelength. So we can say to produce a standing wave for equation 1, let us call this as equation 1, it should be superimposed by another wave that has same amplitude, frequency, and wavelength. So all these three parameters should be same, but in opposite direction. But traveling in opposite direction. So therefore, we can write that the superimposed wave, thus the superimposed wave, if it is represented as y prime, that will be equal to a cos of kx, and we have here omega t and plus phi, and this phi will be equal to pi, because one is traveling to the left side. Suppose another will be traveling from left to right, and another one will be traveling from right to left. This will be result in the superimposition of the wave, or rather we can say standing wave. So plus, so we can say from here the phase angle will be phi, traveling in opposite direction, therefore phi is equal to pi. We substitute here y prime is equal to a cos of kx plus omega t plus pi, and this will be giving us minus a cos of kx plus omega t. So therefore, we get the answer that the superimposed wave should be equal to a cos of kx plus omega t. So this is the equation for the superimposed wave, but we can also verify it with which states that it forms a stationary wave such that point x is equal to naught is a node. So let's try to verify it. Let us superimpose these two waves. This is superimposition of two waves. That is represented as yt, that will be y plus y prime. So we can write this as a cos of kx minus omega t, and we have this as plus minus of a cos of kx plus omega t. So we can use the formula and trigonometric formula. So we can say our yt will be equal to, we have 2a, and this will be coming as sine of kt and multiply by sine of omega t, sine of kx. Now it is having two components rather. One component is our sine of kx and another component is sine of omega t. So this sine of omega t component, it is the oscillations with respect to time, or rather we can say it represents oscillations in time. And the second component, that is sine of kx, this represents the spatial component. This represents the spatial component. With nodes, and you can say nodes and antinodes, like we said previously also, is defined by the spatial component. So you can say this spatial component with nodes and nodes basically means the place where amplitude is 0, points of 0 amplitude, that is where sine of kx is equal to 0. So therefore, as soon as we put x equal to 0 in this equation, we get sine of k of 0 will be equal to 0. So we try to formalize it. Therefore, we can say for x is equal to 0, we have sine of kx is equal to 0. That is node at x equal to 0, which was put forward in the question itself, that the point x is equal to 0 is a node. Thus we proved that the superposition is going to give us a node at x equal to 0. And if we check the options that are available to us, we can say that the option is our minus. So the options that are given to us, we can say that option number C is the correct option. You can write option C is correct. So this completes the question. Thank you.